Hello everyone. Now we'll be discussing about mathematical analysis of recursive algorithms. As we know, as we have already studied how to analyze the non-recursive algorithms. So this is the next topic in that how to analyze the recursive algorithms. Now these are the steps like the previous one. There is slight difference in this. First three steps are same, but when it comes to fourth step, we have to find a recurrence relation. Since it is a recursive algorithms, we have to find out the recurrence relation with an appropriate initial condition for the number of times the basic operation is executed. And the fifth one is solve the recurrence for at least ascertain the order of growth of its solution. So we have to solve the recurrence relation. And hope you know how to solve the recurrence relation. You can use two methods for this. One is substitution method and the other one is Master's theorem. So any of these method you can use to solve recurrence relation based on the recurrence relation that we are getting it. So we will solve the example so that you will know better about it. Say that first one is factorial. We have already know what is factorial of a function, how to find out how to write the recursive function for this. So what is a recursive function? If n is equal to 0, return 1, else return f of n minus 1 into n. Now, this question has been asked in the 2015 onwards. Around 2 to 3 question paper, the same question has been asked. So how to solve this one? How to write the recurrence relation for this? The recurrence relation is what? M of, if I type it as a m of n, multiplication, number of multiplications needed. M of n is equal to m of n minus 1 plus 1. That means how many multiplication needed? F of m minus 1 multiplication needed plus 1 more, this multiplication also. So that's what to compute f of n minus 1, we need m of n minus 1 computations, multiplication. And to multiply f of n minus 1 by n, we need 1 more. So you know how to solve this one. M of n is equal to m of n minus 1. You are using the substitution method here. And m of 0, if it is 0 what? How many multiplications? 0 multiplication. So m of 0 is equal to 0 also is there for n is equal to 0. Now substitute. How to substitute the values? M of n is equal to m of n minus 1 plus 1. Now we can substitute m of, what is m of n minus 1? M of n minus 1 is equal to m of n minus 2 plus 1. So substitute these value here. So when you know, when you see this one, when you solve this one, you will be able to know, right? This one you are substituting it here. So this is this. Okay, and this plus 1 is this plus 1. Now again, m of n minus 2 plus 2 you got from this. This gives this m of n minus 2 plus 2. Now you know what is m minus 2. What is m minus 2? M of n minus 2, m of n minus 3 plus 1. Substitute this one here. You will get m of n minus 3 plus 1 plus 2. So you will get here m of n minus 3 plus 3. Now generally you can write, these are same, right? So write this I. M of n minus I plus I. Now which can be, in order to get m of 0, so we should have the only initial condition, that is m of 0. How to get m of 0 from this? If you substitute the value I is equal to n, you will get what? M of 0, correct? N minus n, 0. So when you substitute I here n, you should substitute here also I is equal to n. That's what m of n minus 1 plus n. You will get m of 0 plus n. What is m of 0? 0. So 0 plus n is what? N. You will get it as m of n is, so number of multiplication needed is what? N multiplication. So this is the way you have to do this. Another one is another famous example for the recursive algorithm is Tower of Hanoi problem. As you know what is Tower of Hanoi problem, you will be getting some needles and you will be getting a disc, and you have to change the disc from one needle to another needle in such a way that only one disc should be placed or should be separated at a time, should be moved at a time, and always the smaller disc should be on the top of this bigger one. So this is an example given. So there are 3 needles. This is source, destination and auxiliary one. That is, we are using a temporary one. You have to move all the disc from here to here by using this. And when you write this one, no, this is the algorithm for this. Move top. What we will do from here is we will move n minus 1 disc from the top, and we will keep it here. Then we will put this source into the correct position, and from there only we will be moving this one. We have already discussed in the previous subject also, data structure also the same thing. Now how to write this one? See, m of n is equal to m of n minus 1 plus 1 plus m of n minus 1. How you got m of n minus 1? The first m of n minus 1 is for moving the top n minus 1 list. And what is this one for? This one is for n minus 1 ABC. And what is this m of n minus 1? That is for top n minus 1 list. So you will be getting this one. Now you have one, if you have only one disk, how many disks you have to move? Only one disk. So 1, that was you got m of 1 is equal to 1. Now in the same backward substitution method, you have to substitute here. So as we know, m of n minus 1 is what? M of n minus 2, 2m of n minus 2 plus 1. This one will be substituted here, and this is the same one. And when you substitute this one, no, you will get here like this: 2 square m of n minus 2 plus 2 plus 1. Now you can substitute m of n minus 2. What is m of n minus 2? That is 2m of n minus 3 plus 1. That will be substituted here, and you will be getting after this 2 cube. So like that, at the end you can write it as 2 power I m of n minus I plus 2 power I minus 1. When you solve all these things, you will get this one 2 n minus 1. So we can write this one as theta of 2 power n. Why? 2 power n minus 1 is always less than 2 power n. So you can write it as theta of 2 power n. This is another example for doing the recursive problems. Now, another thing is binary representation that we have already discussed non-recursive algorithm for this. Now we are discussing the recursive algorithm. How to convert this one? That means number of digits, binary digits in the binary representation. How we'll find out? Binary of n by 2 plus 1. That means we are dividing this one into 2 half, and we are finding out the binary representation for this. So this one is also 1. If it is equal to 1 means only what value is what? 1. So see, if it is equal to 1 means it will be 0. There is no comparisons to be done in this, or no division to be done in this. And when you see, this is the equation you are getting: a of 2 power k is equal to a of 2 power k minus 1 plus 1. Same, you will substitute all the values in this, and you will get it back. And at the end you will get log n. That means you can write as theta of log n for the binary representation. So mainly non-recursive algorithms, when you study the mathematical analysis, it includes 4 examples to do that. But when you do the recursive algorithm, you have to study 3 examples. One is factorial, and the one is binary representation, and the other one is Tower of Hanoi. And sometimes in the question paper also, there's a few times they have asked about the Fibonacci series also. You know, right, Fibonacci series, how to do it. F of n is equal to f of n minus 1 plus f of n minus 2. And f of 1 is equal to 0, and f of 0 is equal to 1, and f of 1 is equal to 1. That is the value, basic condition for that. So what we will do is same method we have to do in that also. We have to find out the recurrence relation, solve the recurrence relation using substitution method. Backward substitutions you have to use in that, and at the end you will be able to solve this one and write it in the form of a asymptotic notation. So this is the overall process for doing this one. So the main step you have to follow here is, for every solution you have to find, these are the plan for that. So first you have to decide a parameter, then basic operation, number of times the basic operation is executed, set up a recurrence relation, and solve the recurrence relation. These are the 5 steps for solving the time efficiency of the recursive algorithms. So hope you understood this topic, and if you have any doubt you can ask me directly, and try solving all these things by yourself, the substitution method, because it is little confusing. So when you solve it, it will be easy for you too after solving 1 or 2 problems. So hope you understood this topic. That's all for today. Thank you.